Hey guys, just want to show you some quick tips using Maple efficiently. So first, obviously, we can enter expressions by typing their keyword and hitting escape and enter. And then we can write whatever we want under the radical and escape by hitting R. Another way to escape, if we're somewhere in here, you can hit Control / and it'll bring you out of a nested expression. Okay? And then there's also, you can do this for E and all sorts of things. I think nth root is one. So you can do a cube root real easy. Let's see, 27. There you go. And you can, there's two ways to assign variables. You can either assign it from the side and type a name. You can also do your name : equals and then your expression. Okay. And so, one thing you're going to run across, especially if you're doing differential equations, is you're going to want to check the results of second order, third order equations in terms of another expression. So you might want to have a shorter way of putting which order of differential you want. Okay, so there's all sorts of ways to do it. There's the Leibniz notation is probably the least ambiguous. So if we want to find the differential, say t of y, okay, it'll ignore the x. I mean, technically that's a partial derivative, but there's another way to do this, is with the prime symbol. Now, if you're dealing with systems of differential equations, you have to be very careful, because in most cases this notation will default to x. So this will completely ignore the t and consider it a constant. But if we're using parameterized equations in terms of t, it's actually less ambiguous to use dot notation. I know, the really ugly dot notation. So you can get it from the side here. Type y, puts the dot over there, and it'll differentiate with respect to t, always t. It's always time. Another faster way to get it is to type it, and then type Control Shift and quotation marks, and then you can just type a period on top. So you could do however many you want, and it'll give you first, second order, third order. So that's really useful if you want to define an expression in terms of another differential equation. So we can define x in terms of this y, doing something like 3 times second derivative plus 5 times the expression itself. Yep. Yeah. Should work. Okay, typically you won't have an x in your differential. That's the problem I was having. Let's do something like that. Okay. So then we can define x say 5 times y second order plus 3 times just y, and there you go. It'll do everything, and the dot notation will make sure that it's with respect to t, always. If you use the prime notation and you do these nested differential expressions, you're going to run into problems because it'll default to evaluating in terms of x, and you won't get the right answer you want. Okay.